Okay, so let's talk about the risk management and the compliance
Sure.
for the engineer. So how do you believe that the updated standard will impact compliance and risk management for engineers in the robotics field?
It's at least as important as it was in the previous edition. And in fact, in some ways, I think more so, because what happens when you have, you have the collaborative robot systems or collaborative robot applications and the mobile. I'm going to not talk a huge amount about mobile right now because 10 to 18 per se doesn't necessarily get into mobile. 10 to 18 is about the industrial robot or essentially a manipulator or arm, and it kind of stops stating requirements at the point where the arm is bolted onto something, whether that something is a fixed in place installation in a factory or a mobile platform that can move around is the 10 to 18 is silent to it. So the concept of mobile robot safety is probably the topic of a different conversation. But
Okay.
you do have more and more collaborative robot applications being used. And now be aware, though, that the vast majority of systems sold are still of the non-collaborative type. So it's still very relevant to talk about the kind of the old-fashioned safeguarded space type of robot safety. Definitely collaborative robotics is an area of growth, and more companies are doing it. And using the Power and Force Limited or PFL robot is believed to be, more user friendly, and that a non-expert can start using it, can get up to speed more quickly than in the non-PFL robots. We're seeing much more quick adoption and uptake of robotics in industry, but we're also seeing robots move outside of an industrial setting per se. So we're seeing more robots being used in restaurants and on construction sites, and these are places that, would not strictly speaking be considered industrial, even though they might be a workplace, but they're not an industrial workplace. And so it's a bit of a gray area whether or not 10 to 18 actually applies to them. The more these machines get out of the safeguarded space and get, in other words, the safety cage. So the more they get out of their safety cage and people can approach them, and then the more they get off the shop floor and out of the industrial setting, um, it's even more important to keep people safe. Because in the industrial setting, one of the things that you can kind of count on is that everyone there, it's a controlled environment. Everyone there has some kind of economic reason to be there and has some kind of economic relationship with the facility owner, which is the robot user. And so, whether they're a direct employee or um, you know, a contractor, they have some kind of employment-like relationship there. And the user has a responsibility to keep them safe, but also can institute rules like before you come into my facility, you have to watch this safety video, and that can help you understand what you should and should not do to keep yourself safe. And so, and so the industrial setting is a controlled setting. You can assume that it's working age and working capable adults who can be trained on how to interact with the system in a way that will help them keep themselves safe. When you start moving out of that setting, now, and you're into public facing, now you don't know for sure if the person that's interacting with that robot in a non-industrial setting might not even be an adult, might be a child that doesn't have a good sense of what's safe and what's not. Certainly, almost certainly is not trained, and really, uh, there would be difficulty in figuring out how to even train. So when you start moving out of the industrial space, it actually becomes even more difficult to keep people safe. And and so, in fact, the engineer's job of creating a system that will keep people safe is actually made even more complex. In the pre-collaborative era, we had the older paradigm is you define the robot's working space, and that's the area that can be swept by the robot arm and its any associated end effectors. Um, and that area is its working space. That's considered the hazard zone, okay? Because if a person can go in there, they can be struck by that robot or the end effector or the workpiece, and they can be injured. So, in order to keep people safe around that robot while it's operating in automatic mode, um, you it it the old paradigm was you put a fence around it or some other safeguarding such as a sensor, a light curtain, etc. So now you've created what's called a safeguarded space around the working space. And so the safeguarded space is the area in which safeguards prevent humans from approaching the machine while it's working in automatic mode. And so how you kept people safe around robots while they were working was you kept them physically separated from robots while they were working. And so, either you had a literal fence, the safeguard with an interlock door. And how that worked is when you opened the door, the machinery would shut off and it would come to a safe state, and then the person could approach it. And if you used a sensor-based safeguarding system instead of a literal fence, like say you had a light curtain, essentially the same thing happened. When you broke the light curtain and the sensor detected a person was there, it shut the machine down. So, um, that paradigm I want to point out is very much still relevant today, very much. And like I said, is still the majority of systems being sold today. But and I'm not going to say that that wasn't complex. That was a very complex system, and and the people who prepare those systems in order to keep people safe, who are working with them, are doing a great job, and they need to be commended for the work that they're doing. When you take away the safeguarding, and or like this is oversimplification, but basically when you take away the fence and you permit the humans to approach the machine while it's working, aka collaborative operation, um, the 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 need to keep people safe just becomes like an order of magnitude more complex for the engineers designing that system, because now you have to limit and monitor the forces and speeds that robot arm can move, and or you have to incorporate a much more complex system of sensors that detect when a person is moving from one zone to another, in the case of speed and separation monitoring type of collaboration. So um, the, the job of the engineer that's designing that system is actually more complicated than the job of the engineer who is, put a fence around it, problem solved. So, and that's in the industrial space. When you go outside of the industrial space, it's even more so. So what I would like to see, my personal opinion as the director of standards development for robotics at A3 is I would love to see the best practices that we have, that we as an industry have instituted in the industrial space. I'd love to see us build on that to ensure that public-facing robots or service robots, once they get out of the industrial space, that we're building on that same degree of safety that we've been able to maintain for 40 years in the industrial space.
It's going to get even more complex because the last couple events I've gone to with the humanoid robots, we have
Yeah.
those in the industrial space, but then we also have them, helping in the medical field and
Hmm.
in service fields, and that's another whole level. I would imagine you
Yeah.
guys are probably hard at work already thinking about that next level when you get to the humanoid robots.
Yeah. In fact, yeah. So, um, the thing about one one thing to know about standards is it's really important. Okay, in the ISO world, the ideal situation is that um, all scopes are covered and no scope is covered by more than one standard. Because when you have overlapping scopes, and when you have two standards that could arguably be covering the same scope, it's confusing. And when you get into safety, you don't want confusion. So in a perfect world, in the ISO view, you would have a bunch of standards whose scopes line up exactly and don't overlap. And so the scope statement of a given standard is really, really important because the experts who are writing that standard are only able to state the requirements for safety within that particular stated scope that they have. And so, like I said, the 10.2.18 is for industrial robot manipulator arms, and it essentially stops where the arm is attached to something. And so, likewise, it's very difficult to define what even is a humanoid robot. Um, um, and also, whatever the special concerns of safety around a humanoid robot are, they might also apply to a quadruped robot. And there are other classes of robots. So, in fact, we are currently having a ballot that's open in TC 299 as to whether or not we should start a new project on what we're calling industrial mobile robots with actively controlled stability. And that lengthy mouthful of syllables is the term that we're using to describe the robots whose class includes humanoids as well as other things.
Right.
So
And the quadruped like spot. Yeah.
yes, yes.
Yeah.
And so the industrial mobile robots with actively controlled stability are essentially robots that um, they um, they need to maintain their power on so that they can maintain their stability because they're actively controlling their stability at all times. And so so the approach has to be different than a machine that you can push the e-stop because when you push the e-stop, if this machine that requires actively controlled stability loses power, it could actually create a hazard by toppling over on you. And so we have made a proposal to TC 299 that the ISO Technical Committee 299 Robotics should open a new project on safety requirements for the industrial mobile robot with actively controlled stability. And that will cover the humanoid case as well as the quadrupeds, as well as any other balancing type robot, of which there are some balancing robots on wheels. That ballot is open right now, and I can't really speculate on how that's going to go. That's against, the ISO rules don't allow me to speculate on that, but that ballot is open now, so we'll see how it goes.
That's great. That's really good news. So, what changes do you foresee in the design process now that cybersecurity standards have been included in this updated standard? And how should engineers approach this new aspect of safety?
Yeah, I think cybersecurity, and again, going back to 2011, the previous edition, we didn't really talk about cybersecurity. I want to say much, if at all, maybe not at all. Um, in that day, the industrial robot and its controller were largely a standalone machine on the shop floor. They really weren't connected to the industrial Internet of Things. And in order to make changes to the programming of that robot, or largely any other ancillary equipment that was part of the cell, you really had to be on the shop floor with a teach pendant. And, that's still largely true today, but it's definitely changing. So you're now seeing more people asking, well, why can't I control my robot using my cell phone like I can control many other things using my cell phone? And even in people's regular life, we're getting much more comfortable controlling things remotely using our cell phones. And so, now we definitely have to be more concerned about cybersecurity than we were in 2011. So it's definitely becoming a much bigger deal. And the more we connect things, the more of a big deal it is. And so essentially okay, there's a couple of considerations here. Number one, many, if of the issues, I'm um, I'm not going to say most, but I would say a large proportion of the issues that arise from cybersecurity lacks, the lack of cybersecurity, are economic risks. So it's the risk that um, some bad actor could change something that results in you wasting a lot of raw materials and ending up with output that you can't use. So that's an economic risk. It's it seems less likely that the risks involved are to do with injury to humans. Not impossible, but less likely. And so, as a safety standard, 10218 is really mostly concerned with injury to humans. So, a safety standard means, we want to make sure everyone goes home with the same number of fingers they started out with. That particular risk is maybe not the hugest risk related to cybersecurity. Not going to say it doesn't happen or couldn't happen, but it's more of an economic risk. But nevertheless, because it is conceivable, we did include it in this year's 2025 edition. We didn't think we had to reinvent the wheel because the issue of cybersecurity per se has been grappled with now for decades in for example, the financial sector, the healthcare sector. And so, there's no need for us to reinvent the wheel. The issue of a malicious actor or unauthorized actor getting access to your machine is how to prevent that is, probably not a lot different than how to prevent the malicious actor from getting access to your financial records. So we essentially, in this new standard, we are largely pointing to existing cybersecurity standards that have been, proven effective in other realms. On the basis of what we've added about cybersecurity in the 10 to 18 2025 edition, what we're asking is that as we are rushing to connect everything, that we just pause a minute and make sure that we are incorporating cybersecurity best practices into the connection of industrial robots and everything else. Just take a pause, take a look at these cybersecurity standards, and make sure that we're handling that issue as well as a myriad of other issues.